Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to Geeks for Geeks and welcome back to another problem of the day as well. So quickly give me a +1 if my voice is clearly audible to everyone and everything is working fine so that we can start off. So just quickly give me a +1 and hit the like button so that we can start off with the problem of the day. That was for Friday. Just a quick +1 in the chat everyone and then we will start right away. I'm just waiting for your responses in the chat. Okay. So everyone is giving a +1. Hi Hassan, hi Keem, hi Shreya. Uh, Hi everyone. Okay, great. So let's get started off with the problem now. So I'll quickly present my screen. Just a second. So let's start off by sharing the screen. I hope that it is visible now. All right. So let's start off. All right. So if you will click on GFG POD, now when we go to this tab, so we can obviously see that the problem for Friday, that was 4th of November, it was based equivalence. So how many of you were able to solve this problem? Just quickly give me a +1 in the chat. Were you able to solve this problem? Yes or no? What was your thought process about it? You can also tell me that. All right. Okay, now let's get started with the problem first of all. So the problem basically says that base equivalence, right? So it says that you'll be given a number n and you'll be given number of digits m. Basically, one thing is there that the number n is given here. Now you have to do what? You have to represent, like you will be given the number n and you have to represent m number of digits. Okay, so you have to check if we can present n by using exactly m digits in any base. Now, what does that mean? So let's quickly look into the example. Let's say n is given as 8 and m is given as 2. Okay, so let's say that n is given as 8 and we have been given m as 2, right? So m is nothing but it is base, right? It is base, right? You know what is base? You know what is base? If we talk about base, right, two base, right, decimal bases, right, 10 decimal, like you know about bases, right? Like if you talk about base 2, the base 2 is nothing but binary, right? You talk about like 0 0 0 1 1 0 0 and stuff like that, correct? Please write a +1. You know this, the base. When m is given as 2, then the base will be considered as 2. Like that means that this means that 0 0 0 1 1 0 1 1, all this kind of numbers, right? Yes, binary numbers, correct? Okay, you know also one more thing, right? You know about the decimal base, right? Decimal base, right? What does decimal base means? Like to the base 10 basically, right? To the base 10. If you talk about the base 10, then what is base 10? In base 10, what happens? Every digit is between 0 to 9. Basically, base 10 means all 0 to 9. Now, every number will be represented like this. You can say 0 will be represented like 0. 1 will be represented by what? 1. 2 will be represented with 2. 3 will be with 3, right? And so on and so forth. So this is very basic decimal base. If I talk about this particular base, that is binary base, right? So in that case, you will represent what? 0 0 first of all, that will represent 0. Then you will basically say that, okay, I have 0, I have 1 here, right? I'll change it. So this becomes 1. Then I'll have what? Then I'll have, like, I have used 0 here, so I'll use 1 and then 0 here. So this will be nothing but 2. Then since I have used 0 here, so I'll use 1, like 1 and this one also. So this will be 3. Then I can see that all this have become 1. So what I'll do is now I can say that this is was 0, so I'll mark it as 1 and this will be 0. this will also be 0, right? So this will be nothing but 4. So that is the game with the bases. Now how many digits are there in this particular, like if I talk about this, so for representing 4, how many bases are, like how many digits I'm taking overall? I can say 3, correct? Please write 3 in the chat. Correct? Can I say this? For representing 4, if somebody will say that, okay, 4, represent 4 in the base 2. So he'll tell me that, okay, 4 is there. So I'll divide it by 2, right? So I'll get a 2 here. So basically this is 0. Then I'll divide by 2. Then I'll get a 1 here, right? So 0, 1. So if I write it upwards, so 1, 0, 0, right? Basically in binary format, or in the base 2 format, it will be represented like 1 0 0. That is nothing but overall 3 digits. Please hit the like button, guys, and give me a +1 in the chat if everyone is clear with this. Okay, bye. Can you tell summaries from the start, yaar? Actually, which part you are missing, Mohammed? If you will tell me that, that will be much more better for me. Now in this case, if you'll observe, if we write for 3 now, if we talk about base 3, okay, now let's learn about base 3. How does the base 3 work? Okay, so if we talk about base 3 now, so here what happens when I talk about base 2, right? When I talk about base 2, can I say that the in base 2, whatever numbers I'm writing, they are present from 0 to 1, right? Basically either that particular is thing is 0 or it is 1. Now in base 3, what happens? You have three options: 0, 1 and 2. Okay, that means less than this 3, right? Basically if you talk about base 10, so 0 to 9 you have numbers and you place it somehow, right? So in base 3 you have 0, 1, like 0, 1 and 2. Please write +1 in the chat. Okay, in base 3 you have 0, 1 and 3, 2. Now when we talk about base 3, right? When we talk about base 3, so if you'll observe, we'll have what? We'll have 0. Like let's talk about the first number. So how will you represent 0? So for representing 0, let's say this is the integer. How will you represent the integer 0? You'll directly write 0. Then you'll write 1 to represent 1, let's say. Then you'll write 2 to represent, let's say, 2. Then after that, what happens? Can I say that everything here gets saturated, right? You have used 0 for this place, 1 for this place, 2 for this place, right? And you can imagine that this particular position, this particular hypothetical position, basically, it is what? It is 0. So now you will do what? You will simply say that, okay, now I'm going to mark it as 1. So this is 0 0, you can say, right? Basically it does not have any value. Now you'll mark it as 1 and you'll have this as 0. So this will be nothing but 3. Now what I'll do here is I'll have 1 and 1 and I'll mark it as 4, right? Then I'll have 1 and 2 because I have used 0, I've used 1, I'll be using 2. So this will be nothing but 5. Then what will happen? Every at this particular position, you can see that I have used every digit. Here I've used 1, right? And I've already used 0, so I'll use 2. Okay, so what I'll do here is I'll use 2 and 0. So this will be nothing but 6. Then I'll use 2 and 1. Then that will be nothing but 7. Then I'll have 2 and 2. So that will be nothing but 8. Okay, is that clear to everyone? Is that clear to everyone? So basically you need to understand that here, if we talk about 20, if we talk about 8, right? If we talk about the number 8 in base 3, in base 3, how many digits I am taking? I'm taking two digits now, because like it is nothing but 22, right? 2 2, it is 2 2. In base 3 it is 8 is represented as 2 2, which take 2, which is total 2 digits, right? So that is why in this problem, if you'll observe, so it says that if m is equal to 8, if m is equal to 8, that is the number 8, right? If you have to represent the number 8, right? If you have to represent the number 8 and m is equal to 2, so basically if you have to see this, right, you have to represent it in two digits, right? So I can say that I can do that, right? I can like if 8 is there, right? So is there any base which like m is what? M is nothing but the number of digits, right? So this is nothing but 2. So can I say that if I convert 8 in the base 3, if I convert it in the base 3, then in this particular case, if I convert it to the base 3, then I will get what? I'll get 22, like 2 2. Basically total number of digits is what? Two digits, right? And that is what the question is asking, that like from starting from the, like you will say that like every number, what you have to try to do is, you have 8, you have basically this number 8. Now you have to find any representation. Let's say you can represent it in two, like binary, like base to the base 2 to the base 3 or anything. Like if you have 8, right? If you have 8, let's say if you have 8, right? Understand this thing. I'm repeating this again, Hussein. See, if you have 8 here, now if you convert this thing to the binary, so this will be nothing but 2, this will be 4, now this will be 2, this will be 2, this will be 2, this will be 1. Okay, so now it will become what? 1 0 0 0. So for representing 8, I'm taking how, like in the base 2, you can say, how many digits am I taking? I'm taking 4 digits. Now you can write 4 in the chat. Correct. I'm taking 4 digits. right? For representing 8 in the base 3, I've already said that I'm taking how many digits? I'm taking total 2 digits, 2 digits. Okay, so it says that you will be given a number m, and you have to tell that from any base starting from 2 till 32, can you represent that number? Can you represent that number in the base, like in 2 digits? Okay, in any base. Is that clear? Please write a clear in the chat, everyone, and hit the like button as well. Is everyone clear with this? Everyone is clear with this part, right? See, if you have 8, right? So what you did with 8, if you have 8, then you check it with the base 2. Like you check it, you convert it into the base 2, and you count the number of digits that you've taken. It is 4, so it is not equal to m, because they want to see if m is equal to 2 is possible or not, right? 2, can you represent it in 2 digits? Now you take 8, like you take 8 again with the base as 3. So if you see 8, how did you get this 22? If you see 8, you divide it by 3, what do you get? You get 2 here. So basically the remainder here is 2 when you divide 8 by 2. Then you divide this, so 2, then this is 0. So nothing but 20, like 2 2, right? You write it upwards, so this is nothing but 2 2. Similarly, if you have to represent it by 4, so you divide. So basically what you will do is, you will be having the number n, and you will first of all try to convert it to the base 2, and you'll count. Please write count in the chat. You will do what? You will count the number of digits there. Then you will try it, if that is like if the count is equal to m or not, right? Because you have to represent, you have to tell that whether you can represent it in m digits or not in any base. Then you'll try to see for the base 3, and you'll say that okay, the count does the count equal to m? Then you will if not, then you will say that okay, for the base 4 I'll try to check that whether the count of the digits in the base 4 for this particular number n, it is equal to m or not. In that case, I'll write a yes. Yes, is that clear, Himanshu? Okay, a little bit confused. Okay, so see, again, see, if I had n is equal to 8, okay, if I had n is equal to 8, so they are asking me that, is there any base, in which in 2 digits I can represent this 8? Okay, so see, in that case you will say that okay, I'll try to convert it into the base 2. So I'll say that 8 is there, right? So you'll write 4, you'll write 2 here, you'll write 2 here. So basically you will play the division game here, right? So you'll say that okay, 0 0 0 and 1. So how many digits I'm taking? 4 digits now, because 1 0 0 0 0. So you'll say that you are taking total 4 digits, right? That is not equal to m. That is not equal to m. Okay. Then you'll say that okay, now n is equal to 8 again. Let's see. And then I'll try to convert it to the base 3. So I'll say that okay, 8 is there. Now remainder is 3. Then sorry, remainder is nothing but 2. Then I'll have 3. Okay. No, 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 that is not the case. Okay. Now you'll have divided by 2, then you'll have 22. So here what will happen? You will have nothing but 22 here, right? 22. And you can say how many digits I'm taking in 22? 2 digits, na? Correct? I'm taking nothing but 2 digits here. Is that clear? Is this part clear to everyone? Please tell me, guys. Is it clear to everyone? Yes or no? And if you have understood this thing, you can hit the like button as well. Is everyone clear with this? I hope that I've explained it properly. For a given number n, you want to see in any particular base, can you represent it in 2 digits, right? M digits, basically, right? You can say m digits. Can you represent a given number with any of the bases as m digits? So basically, you try to like you have 8, so you try to convert it to the base 2. Like then in that case, you'll have 4 digits, but you want 2 digits here. M is equal to 2, so you will say no. Then you will have 8. Then you try to divide it by 3, basically convert it to 3, so you count. Now you see that okay, it will get converted to 2 2, right, to the base 3. So now you say that okay, total 2 digits I'm taking, right? This is what we are doing. Okay, everyone can write a clear in the chat. Great. So what will I do for this? I'll simply say that what should I do? So I'll simply say that for, like, I'll iterate from where? I'll say that okay, for int I starts from nothing but 2, I is less or equal to 32, and then I'll say that that I plus plus, right? So for all the bases I'll try, no, I'll try to convert it for each and every base. Like whenever I'll get the number of digits in a particular base as m, then I will simply return a yes. Otherwise I have to return no, because if you see n is equal to 8 and m is equal to 3, so can I represent 8 with 3 digits in any base? No. So that is why the answer here is no. Okay, because you can see that like when n was 8, then if I convert 8 in the base 3, then I could represent it with 2 digits, that was 22. Correct. So I'll try to run for every, please write each in the chat. I'll try to run for each and every base. So what I'll try to do is I'll try to say that okay, I starts from 2, I is less or equal to 32. and then an I plus plus. Now what I'll do is I'll mark the count as 0. Okay. And then I'll use the temp because I'm going to divide the number. So I don't want to lose the original number. This is why I'll do it. Then what I'll do is until the time the number is greater than 0, because you can see this is nothing but what division process, na? Division process. So as many number of times I keep on dividing until it becomes 0, because here it will become 0. So 1, 2, 3, 4 times. 4 times n was greater than 0, the temp was greater than 0, so I divided it. So what I will do here is I'll say that while the temp is greater than 0, I'll simply do a count plus plus, and then I'll say that temp divide is equal to I, because I'll keep on dividing it by the ith base, right? If I have let's say I is equal to 2, basically if I want to check with the base 2, so I'll divide it by 2 divided by 2 divided by 2, right? So 4 times I'm going to divide it by 2, so that means 4 digits total will be there, right? So but I want m digits. So if after dividing, like if after dividing, if the number of digits, if the count of the digits is equal to nothing but m, in that case what should I do? I should return that yes, it is possible for me to represent this given number m in like n in m number of digits with any of the bases. Obviously I don't need to return that particular base, I just want to return whether it's possible or not. Otherwise I'll return false, so you can say no. Is that clear to everyone? Now let's try and compile this code and check it works on the samples. All right, let's try and test it as well. Okay, so it gets accepted. Is it clear to everyone? Is the code clear to everyone? What I'm trying to do is I'm trying to basically check it for each and every base. Okay, I'm trying to check from I is equal to 2 till 32. I'm trying to check it for each and every base. So for the ith base, every time I'm trying to clear, trying to check, and I'm trying to mark the number of digits for that particular base as 0, and then I'm storing the number n in temp so that I don't lose the number n. And while the number is greater than 0, basically this particular type of division that we do here, you can see I've highlighted it with yellow color, or you can say green color. This type of division that we try to do, that is what I'm trying to do. While if the ith number in less than m can be returned no immediately. Okay, but it is a different question than this. He's saying that while iterating for a base, the number of digits required less than m can we return no, basically, but we need to check for that also, like what exact statement is there. You cannot say that directly, you need to analyze a lot of circumstances and test cases in that case. Okay, Rishit, you cannot say it directly, we cannot predict it directly, because there might be some edge cases for which your thought process might not be true. So for this case, I cannot directly say. I also need to figure out on those cases. But is the question clear to everyone? Overall, the thought process for this question is clear to everyone. Please hit the like button, guys, and let me know. Is everyone clear with this approach? You can quickly write a clear in the chat if you're clear with it. Everyone is clear with this? Is there something more that you want me to explain? If you're clear, then you can write clear once again, or a +1 in the chat as well. Because this problem was quite easy. Like, you can write easy in the chat as well if you think it was easy. It was quite easy. Basically, for each and every base, you can simply check by iterating and counting the number of bits, and if by iterating and counting the number of digits in that particular base, if the number of digits in that particular in a particular base is equal to m, that is the required number of digits that you want, then you will return yes, otherwise no. Okay, all right. So thank you, everyone. I think that this was it for today's problem of the day. It was quite easy. Can we repeat this code, sir? Can we repeat this code? Yeah, sure. Sure, we can repeat it. So basically, what I'm saying is, you will check it for every base. Now, Hussein, see. Basically, if you have n is equal to 8, okay, you need to understand this thing. Suppose that you have this particular thing here. If you have n is equal to 8, okay, and you want to represent it in m is equal to 2, that is 2 digits, okay. So you will say that what like you will say, if you talk about 8, so you will say that okay, 8 is there, right? So you'll divide it by 2 divided by 2 and so on and so forth, divided by 2 divided by 2, right? So it becomes 1000. So you'll say that okay, 1000, like basically 4 times you're dividing now. So in the base 2 there are 4 digits, right? 4 digits, correct. So it is not equal to m, it is not equal to m. So you'll say that okay, I'll try to change my I to 3 and I'll try to convert it to the base 3. Okay, now when you convert it to the base 3, in that case what will happen, you will have 3. Now when you have 3, so what do you have here? You can simply say that now you have 8. So basically you can see that now you will have to 2. and this will be 3, this will be nothing but 0. So basically you can say that overall I'm having 22, like 2 into the base 3, so total 2 digits are there. So that is why it is the count of the digits, that is total 2 digits. This is one digit, this is another digit, is equal to only m only. When it is equal to m only, right, in that case you will return a yes, that okay, it is possible for me to represent in that much number of digits. Now Rishit is saying that what is the time complexity. So you can understand that what I'm doing is I'm basically iterating from 1 to 32, right? You can write constant in the chat. Huh? It is nothing but order of one kind of operation, right? It is nothing but order of one. Why is it order of one? It is order of one simply because I'm like just iterating from very less numbers from 2 to 32, correct? And now talking about this particular code, so you can say that it is nothing but logarithmic of n. Whenever you divide a number, no, whenever you divide a number with a particular base, so it is nothing but you can say logarithmic time complexity, like log time complexity. Is that clear? Like it will be logarithmic in nature. You can say log I, or you can, to be precise, you can say it as log of n. Is that clear? Whenever you divide a number, not order of n, no, not order of n, because you're not dealing with like you're not dealing with an array or n elements, right? It's not nothing like that. So Joel, it will not be order of m. Like see, this is what, this is constant, no? This particular loop is what, a constant time complexity, because I'm iterating from certain set of values, no? From 2 to 32. And then if you will see here, so like whenever you're dividing now, mark my words, whenever you're dividing something, so in that case the complexity becomes nothing but logarithmic of n, you can say, right? Log n, or you can say log I, whatever, but it is basically logarithmic in nature. Is that clear to everyone? Is this part clear? See, if you have this particular thing, if you have, like if you have, like, can I say this, like, see, understand, when you do binary search now, you have n search spaces, n, then n by 2, it reduces to n by 4, n by 8, right? When you do binary search, so you remember that in binary search you mark the complexity as logarithmic of n to the base 2, correct? So that is why, because whenever you're dividing now, so whenever you're dividing by I, so you can say that log n to the base I. Okay, when you're dividing, see, when you talk about binary search, right, when you talk about this particular thing, that is binary search. So when you talk about binary search, so first of all you have search space n size, then n by 2, n by 4, right? So on and so forth till 1. In that case, you will tell me that okay, the time complexity when we are dividing by 2 every time, it is nothing but logarithmic of n to the base 2, right? And similarly, if you are dividing it for every number, so it will be nothing but log of n to the base I, you can say. So it is nothing but logarithmic in nature only. Is that clear to everyone? Just quickly write a clear in the chat, and then we'll end this stream as well. All right. So did you like it? Did you enjoy it? Just quickly hit the like button and let me know, guys. All right. So this was it for today's problem, sir. Didn't know about time complexity. Please teach me, sir. Joel, for now, you can learn, like you can do one thing. You can learn first of all about the time complexity of binary search and other things. Basically, whenever you are dividing, so you'll say that okay, it is whenever you're dividing now, so you'll say that the time complexity is going to be logarithmic. No? Okay. So great everyone. I hope that you enjoyed this particular stream. Thanks a lot for joining for today, and we will meet in another stream. Till then, make sure to take care and goodbye. And just quickly hit the +1 in the chat. Enjoyed a lot. All right, great. So we'll be meeting next time for another problem of the day. Till then, make sure to keep on solving the problem of the days, and I'll also try to be a little bit more regular with the problem of the days. Okay, I will also try to solve them as well. Okay. Yeah. Bye everyone. Bye Joel. Bye Shreya, and bye Rishit. Enjoyed a lot. Okay, just a second. So like Joel is saying, enjoyed a lot. All right, great. Good morning, sir. It's not good morning actually. Thanks a lot, Shreya. Didn't know about time complexity, so no problem. You will understand that, and got it. So thanks a lot, everyone, for joining for today. We will meet in another session. You can search my name, Hussain. My name is Yash Dwivedi. You can search it on LinkedIn, and you will get my profile. Okay, I don't want to share it here. Thanks a lot, everyone, for joining for today, and I'll meet you in another live stream soon. And bye, take care, and happy coding, everyone.